Alright, so if you have ever tried a machine learning model and it performs great on your training data but crashes on your real world data, then yes, that's what overfitting is. Regularization is one of the best ways to deal with that, and today I'm going to walk you through the two most common types of regularization, which is L1 regularization and L2 regularization. We will talk about how they work, what is the actual differences between the two, and when you should use one over the other. I'm not going to go into very deep math. I'm just going to give you a clear intuition. Hello everyone, I am Radhika. Welcome back to Datazard. And now without further ado, let's get started. The first difference between L1 regularization and L2 regularization is in terms of formula. So for L1 regularization, the formula is loss is equal to the original loss plus lambda, which is a hyperparameter, multiplied by summation of mod of wi, and mod of wi is the penalty term that we add to this original loss function. So this penalty term is basically the sum of absolute values of the coefficients, because we are taking absolute values here. In L2 regularization, the formula is our loss function is equal to original loss plus lambda, again this is a hyperparameter, multiplied by summation of wi square. So the penalty term here is we are squaring these coefficients. Now talking about sparsity, L1 regularization drives coefficients to 0 and therefore it encourages sparsity, whereas for L2 regularization, it does not set these coefficients to 0. Our coefficients, they shrink towards 0, but they will never become 0, and therefore we do not experience sparsity in L2 regularization. Then the next difference is in terms of feature selection. So yes, it is used in feature selection. Why? Because again from here, our coefficients are becoming 0, and that's when a coefficient becomes 0, we know that that feature will not be included in predicting, and that's when we know feature selection has happened. Whereas for L2 regularization, it retains all the features. However, their influence is decreased because L2 regularization will shrink those coefficients towards 0. So we are reducing their influence. Outliers. L1 regularization is robust to outliers, and it uses absolute values of coefficients, where we have seen this from the formula over here, whereas L2 regularization is sensitive to outliers because we are here using sum of coefficients, sum of squares of coefficients, and this term is sensitive to outliers. L1 regularization is not differentiable at 0 because it uses absolute values, and absolute values, they are not differentiable at 0. Whereas L2 regularization is differentiable at all points because it uses a quadratic equation, like it forms a quadratic equation. In terms of multicollinearity, L1 regularization handles multicollinearity poorly, whereas L2 regularization handles it better than the L1 regularization. Now the question would be when we should be using L1 regularization and when we should be using L2 regularization. So L1 regularization should be used when you expect the features to be redundant. When you know that some of your features, they are not relevant to the target data, so you can apply L1 regularization. And then the coefficients of these features which are not correlated with the target variable will become 0. And in this way, we are removing those redundant features. And that's exactly what feature selection is. So when feature selection is required, then we should be using it. When we want a sparse model, why a sparse model? Because when we are driving those feature coefficients to 0, we are creating a sparse model. So when we want that, then we can use L1 regularization. When you have a high dimensional data, then L1 regularization can be used because with high dimensional data, again, not all features would be related with the target variable, and that's where feature selection would come in, and then we can perform feature selection there. So these are 4 use cases when applying L1 regularization would give better results as compared to L2 regularization. Now, what are the instances where we should be using L2 regularization? So when we want all the features, that means all the features, they are correlated with our target variable and we want all of them in our prediction, that's when we will use L2 regularization, because it does not make the coefficients of these features to 0. It shrinks them to 0 but never equal to 0. When we have multicollinearity, then we should be using L2 regularization because we know that L2 regularization handles multicollinearity better than L1 regularization. When we do not want sparse data, then we need to use L2 regularization, because if we use L1, then it will create sparse data set. And if we want more stable conversions, then we should be using L2 regularization, because it penalizes large errors more than the smaller ones because of squaring, and this results in more even and gradual shrinkage across all the coefficients. Now you would think, what if my scenario is in between the mix of L1 and L2 regularization? What should we do then? In that case, we can use elastic net algorithm. So for elastic net, the formula would be our original loss function. So loss function is equal to original loss function plus our penalty term for L1 regularization, lambda 1, which is the hyperparameter, multiplied by summation of mod of Wi, plus this is L2 regularization penalty term, lambda 2 multiplied by Wi whole square, multiplied by the coefficient of square of coefficients. So we will get advantage here for both L1 regularization and L2 regularization. So the use case for elastic net is when you need a balance between feature selection and regularization. That's when elastic net comes into play. When you're dealing with multi-collinearity, but you also want sparsity in your data, then you would use elastic net. So if you want benefits of both L1 and L2 regularization, that's when you would use elastic net. So to recap, L1 regularization is great when you want a simpler model that can even drop irrelevant features entirely, while L2 regularization is more about keeping all your features but making sure none of them dominate too much. That is when we are shrinking them to 0. In practice, which one you choose depends on your data and your goals, and honestly, sometimes best move is to try elastic net and let it balance both L1 and L2 regularization. If this helped clarify things, give it a like or drop a question in the comments. Happy to dive deeper or cover other topics like elastic net, feature selection, or model interpretability. Thanks for watching, and I'll see you in my next one.